Assalamualaikum. Hi guys. In this video, we are going to learn about isoelectronic species. So what is that? Iso means same and electronic means electrons. So in this case, usually we are referring to ions, but as general, the definition of isoelectronic means that atoms or ions with the same electronic configuration. So within isoelectronic series, more positive the charge for that species, the size becomes much more smaller. If that species has more negative charge, so the size for that species becomes much more larger. So I hope you are clear how to relate with the previous video, because we know that cation has smaller size compared to its atom, while anion has greater or larger size compared to its neutral atom. So for example, I have here sodium with its corresponding electronic configuration and oxygen. So we know that sodium will donate 1 electron to achieve stability. You can write the electronic configuration for Na plus right now with 10 electrons. 10 electrons here, also same with the electronic configuration for neon with 10 electrons as well. That is why I put square bracket Ne, atomic symbol for neon. Same goes for oxygen. Oxygen will accept 2 electrons to achieve stability. So it has 10 electrons. Same goes for Na plus. So the electronic configuration for O2 minus also the same with electronic configuration for neon. So you can conclude right now, Na plus and O2 minus have the same electronic configuration. As you see here, they got 1s2, 2s2 and 2p6. So they are isoelectronic with neon with 10 electrons. That is how you want to detect isoelectronic species. Let's try one more example. I have here is these ions. So I want you to explain the ionic radii of positive ion and negative ion. So if I simplify them into two parts, I have the ionic radii for Na plus much more greater. This is from period 3. If you take a look here, they are all share the same electronic configuration, 1s2, 2s2, 2p6. So that's why they are isoelectronic to one another. In this case, you can see that the size for Na plus is the largest compared to Si4 plus, because as I mentioned before, within isoelectronic series, the species with more positive charge will have the smaller size. Si4 plus got the most positive charge, that's why its size is the smallest one. Same goes if I simplify them into ionic radii. For negative ion, I have based on period 2. So you can see I have N3 minus, O2 minus and F minus. They are all share the same electronic configuration as well. That's why these 3 ions are isoelectronic to one another. So you can see that the most species with negative charge will have the larger size. That is why N3 minus is the largest compared to F minus in period 2. So now I want to continue more further about this example. I want you to arrange all these species based on their size. Right now we have the species, this one, and you can see that I put the proton number for their respective ion. So now how I want to describe more about this trend, I will write it down based on my arrangement here. I can see that proton number increases from N3 minus until Si4 plus. So that is my first point. So when proton number increases, the effective nuclear charge Zef also increases. Then the nucleus attraction with the valence electrons becomes stronger. So the ionic size will decrease from N3 minus to Si4 plus. So how do I want to write the arrangement right now? I will start with the most greater one, N3 minus, followed by O2 minus, and so on, with Si4 plus as the smallest ion. Let's try one more example. I want you to arrange this species in order of increasing size. So take a look carefully. It is stated what order you need to arrange. So you got argon, K plus, Cl minus, S2 minus, and Ca2 plus. So 5 species here, and you got 1 neutral atom. So the proton number of them are given here. So no matter what, how you want to start this question, write the electronic configuration first. So I got my argon here, K plus, Cl minus, S2 minus, and Ca2 plus. You can see that all of them got the same electronic configuration with 18 electrons. Next, we can say that they are isoelectronic. So within isoelectronic series, I told you before, more positive the charge, the size becomes smaller, and vice versa. So the number of electrons in this species, 5 of them, are the same. So the size will increase in order of Ca2 plus, because Ca2 plus holds the more positive charge. And S2 minus will becomes the largest ion here because it holds the most negative charge. So that is how you want to write the arrangement for species that is isoelectronic based on this example. And make sure you arrange based on the order given in the question. So in this case, I use less than symbol to indicate increasing size. So that's all for this video. I hope you are clear what is isoelectronic species and how to arrange them in terms of their size. So that's it for now. I will see you in the next video. Bye!